Assalamualaikum and very good day to our lecturer Dr. Zulkifli and Dr. Karima. Today we will present about our assignment is power system incident at Friday 13 August 2004. Alright. The accident is mentioned on Friday August 13, 2004 at 2141. A current transformer in the number one bay of the switchyard at Bashwater Bay Water Power Station fell and then blow up. This figure show the number one bay transformers. Alright, next. Protective system on the 34 line found the problem with the current transformer and automatically opened the circuit breaker on the 34 line at both the water power station. The problem was fixed in 83.5 microsecond, which was a plan. The problem with the current transformer was the cut off from the power system by the open circuit. Next, there are auto reclose system on the 34 line between the water power station and leader power station 2. 50 seconds after the first problem, the auto reclose on the 34 line did what it was supposed to do. Next, 34 line protection system restored by water power station. Second issue resolved in 78.5 milliseconds. After failing to auto reclose, the primary bus circuit breaker blocked out. By water unit 1, 2 and 3 automatically tripped. 3 by water generator, 3 differential protection. By water 4 stay synchronized. Rapid loss of generation dropped the frequency to 48.9 Hz. Next is after 60 seconds, the 34 line auto close the coupler circuit breaker as figure. One of the auto feature reclose. After fail line reported at Basewater station and other New South Wales switchyard. Third feature did not cause load shedding. The 34 line protection mechanism re-identify the current transformer feature and reopen the coupler circuit breaker. The fault fixed in 63.0 milliseconds. After failing to auto reclose, the coupler circuit breaker was locked. Okay, is current transformer pressure the protection system involved in this incident is operate and how it's related to the incident. Alright, the nature of the current transformer that occur at Baywater. Tasgate told NEMCO the following. Tasgate has investigated the Baywater transformer breakdown in several ways, but they can't say what caused it. They notify NEMCO that most evidence suggests the current transformer blew up because the considered bushing foil test terminal earthing lead failed. Early 1980s, Tyree Australia made the Baywater switchyard transformer, standard oil and paper insulate high pin. Baywater switchyard opened in 1984. Transgate do not know of any system or environmental circumstance at this site that likely caused the breakdown. Transgate put monitoring device on the current transformer, including the one that broke on August 13, 2004. This monitoring facility may alert people if current transformer fail. The fault was distinct from the 1990 fault. Due to this, monitoring system did not detect the malfunction early. NEMCO believe that pressure mode of the water accident and two previous current, the form breakdown at Tarong and Jeralang are not similar. NEMCO being told by TNSP that it's unusual for them to exchange import asset management information such as import equipment. Alright, next we'll continue with my team member.
Next, we will talk about the root of the incident or the consequences of the incident. So, the airing unit was tripped because of two negative phase sequence trip because of the operation. So it is more into the double line to ground. And then from the preliminary investigation, it also said that the time delay function did not operate correctly on Siemens NPS protection system, and thus the operation is soon detected as fault. Next. Okay, approximately around 36 seconds after the initial fault, the red bank generating unit automatically tripped from 150 megawatts. The red bank project have advised that the unit protection was set to trip when the power system frequency was below 49 hertz for more than 6 seconds, and it also caused the unit to trip. So Lemco also advised that most of the evidence suggested failure is in the earning lead from the condenser bushing fault test terminal caused the current transformer to fail explosively. Next. So the impact of the incident. So from the incident, the failure of the current transformer at the base water switch yard lead to 6 generating unit that lost in the New South Wales. So totaling is around 3,800 megawatt. The loss of this 6 unit generating unit is substantial frequency disturbance on the power system. And then the sudden loss of the generating unit also caused the system frequency to fall to 48.9 hertz. So next slide is, so in terms of safety and health, so there are no death or people that injured during the fault happened because nobody are in the area. And then in the term of cost, so they are only focusing into the repairing the damage in the transformer and then also the transmission line that trip. And the total cost is around $10,000 in total. Thank you.
All right, so the next one is based on the technical report and your own judgment, which society or any issue related to this one. So the first issue is about Australian energy market operator. So basically, this because of this incident, the total generation loss was about 3,100 megawatt, or about 14% of total supply in the national electricity market on Australia was affected. So the Australian energy market operator, in collaboration with network service provider, was helping or involved in this issue to prevent uh, anything happen in the future about this incident similar happen in this future. So, and then move to the next one is what has been or will be done to prevent this event from happening. Next slide. So what has been to prevent this happening in future? So with the collaboration, there have three method or three way to prevent this from happening again in the future. So the first one is about the condition monitoring technique and enhance the condition monitoring technique. So which is all the inspection, the chemical testing for each component at the transformer, physical testing method, and then all this process can be easily applied to equipment that is out of service. However, continuous online technique are preferable as they can provide data trending in short-term notice of an impending failure. So let's move to the next method, that is online technique at base water. So the first online technique is radio-based system. So radio-based system is uh, based on radio frequency, which is during the transformer current failure, a security officer patrolling the switch yard report that in the minute leading to the failure or self-destruction, a large amount of noise was heard superimposed on the AM radio station he was listening to. So consequently, Transgrid or the network provider developed a prototype current transformer condition monitoring system to log radio noise level and ambient temperature in the switch yard over time. So if anything happened to the system, that will this will provide initial frequency or rising frequency or lower frequency, any changes to the frequency of the system. So and then the second one is DDF and insulation resistant. This DDF means device definition file monitor was also commissioned at Basewater. So this system measured the insulation, leakage current, and absolute DDF measurement using the system voltage as reference. So the leakage current and DDF parameter are assessed with the aid of capacitive transducer that are fit between the brushing tap and of the city and earth. So the third method is high frequency transient. Next slide. The high frequency transient. So there are two techniques using on this one. So the first one is observe traveling wave signal. So the traveling wave signal is controlled by remotely at Sydney West Bus Bar that can be observed repeating the initial transient every 1.28 millisecond, corresponding to the transient travel of the Basewater to Sydney West Circuit. So this one is basically on the wave signal. All right. So the second one is partial discharge detection. So upon closer inspection, this appeared to be high frequency discharge that did not originate from the high voltage system. So this due to the lack of recognizable traveling wave deflection, which would be observed approximately 1.28 seconds after the initial transition. So this discharge deflection is when the failure occur, there will be an discharge happen in the transformer. So this will detect initial condition that will remind or alert the system, the controller system. So that's all for the so that's all from our group. So thank you very much and thank you.